Good afternoon, everybody. And for those who I haven't met before, I'm Charles. I'm the Managing Director at CML. I'm joined here today with two of my colleagues. We're going to be hearing from Natasha next, who is a project manager at CML. Natasha is going to be talking to us about some of the actions we take in those first few hours after we're alerted of an emergency response event. And then we're going to hear from Kieran, who's an apprentice at CML. Kieran is now in his final year of his civil engineering degree, and he's going to be talking to us about some of his experiences working on the delivery of emergency works on site and how we as a delivery team manage the various challenges. So whilst we've seen a lot of progress in the industry, including various technological advances, some of which we've been hearing about today, we still see the same types of failures occurring. And the industry clearly needs the ability to be able to respond in these instances. This little back catalogue of disasters on the screen is a small selection of landslide repairs which we've remediated over the years, some dating back to the late 90s. These images show a variety of typical slope failures or movement indicators which we tend to see on the railway, such as leaning OLE masts, displaced troughing, exposed sleep rents, tension cracks, toe bulges, back scars, and there's a few slightly more extreme examples on screen of catastrophic failures where clearly the railway's been brought to a standstill for several days or even weeks. So, are these events preventable or inevitable? I'm sure we could debate this for hours, but today we're going to focus on what we do when the inevitable happens. So, we continue to experience and pay for the side effects of earthworks failures, and it's no great surprise. As we've been hearing this morning, we all have a difficult job as custodians of an ageing railway built on increasingly fragile assets. Network Rail are responsible for over 190,000 earthworks assets. That's a lot to inspect and maintain. The majority of our earthworks are over 100 years old. They're simply not designed to deal with modern day capacity and increasing pressure from more intense weather systems. So our slopes are overly steep, weathering, and we're more likely built with limited quality control in terms of materials and compaction, for example. I'm going to quickly bore you with a few more climate change stats. So we know from data collected from the Met Office, frequency and intensity of storms, droughts, heat waves, it's all increasing. Sea level rises are impacting coastal areas. The Met Office charts on the left, so they're a bit too small to make out. What we can see is that they're all trending upwards. The UK's had 17 record-breaking months of rainfall since 1910. 9 of these have been since the year 2000. 9 of the UK's 10 hottest days on record have occurred since 1990. And sea levels are rising at twice the rate compared to just 20 years ago. So these climate changes and more intense weather systems only add to the stress our earthworks assets are under. And it's no coincidence that the majority of earthwork failures we respond to occur during or shortly after prolonged or intense periods of rainfall. And so the industry relies on all of us to be able to respond quickly and safely to repair the infrastructure, minimise delays, and protect the railway for generations to come. Before we dive into the process we go through in reactive situations, I wanted to very briefly touch on some of the proactive measures which we take, more specifically with the Eastern Region team, which unfortunately for us are very effective, resulting in fewer landslides for us to repair. So thanks for that, Matt. But clearly, some of these simple interventions are very effective at reducing disruption, cost, and the significant safety risks that earthworks failures present to the railway infrastructure. So these have been a few key interventions which have been initiated over the last control period or so. Initially, we used to receive 2-hour response orders to attend high-risk sites during rainfall events to check that sites were okay, that drainage systems are functioning, which is better than doing nothing. In more recent years, as discussed by Matt, in the earlier session, we're now using remote condition monitoring technology to help keep tabs on high-risk sites remotely, using data and real-time visuals to help inform decisions. And by simple monitoring of weather warnings, we now place additional people on call to respond during periods of heavy rainfall. So using a combination of these very simple interventions, we now have a much smarter, more effective approach. We now typically inspect and maintain assets 2 days prior to weather events. Remote condition monitoring can then be used to monitor during, and finally we carry out follow-up inspections after the event. And as seen in the photo on the top right there at Stoke Junction, simple tasks such as keeping trash screens clear will keep drainage systems functioning effectively, preventing blockages and overtopping, which so often results in washout failures, earthworks failures. So whilst these measures may seem simplistic, they are, and they're really quite cost effective too. And we know that these simple interventions have prevented countless earthworks failures. In the recent Storm Babbitt event, where some parts of the UK saw over a month's worth of rainfall in just over a day, we attended 30 sites to undertake preventative site checks. I was going to say with minimal disruption occurring on the network as a result of earthworks failures, but as Sam just alluded to, we've just had 2 call-outs today to go and respond to landslides. So we've clearly got a bit of work to still do there. But clearly this system is worth replicating around the network and further developing to help us continue to reduce the disruption from earthworks failures. But as I mentioned earlier, with an aging infrastructure and more intense weather systems, we currently continue to be unable to prevent landslides entirely. So I'm now going to hand over to Natasha, who's going to talk you through the actions we take during those daunting few hours after the emergency phone rings.
Okay. There we go. Okay, so CML provide on-call cover 24 hours a day, 7 days a week, 365 days a year along the entire eastern route for Network Rail. This means that on any day, we could be required anywhere along that route within as little as 2 hours. And we'll be responding to incidents such as embankment slippages, flooding, or rockfalls, genuinely what it says on my notes. But there are 3 key tasks that we need to complete that will enable us to get a team on site within 2 hours with a safe work environment and in a position to be productive. Today, I'm going to focus on the actions we take in the first hour after we receive an emergency remit. Firstly, desktop studies are a valuable tool to provide existing site information, helping inform our design and delivery teams. We have a wealth of existing data from our own records and sources from the public domain, so we'll talk about how we make this data available in one single database. We'll also take a look at our in-house safe work planning tools, helping us to produce accurate data packs quickly. And we'll look at how we identify local resources so that we can respond to emergencies promptly. These 3 tasks are fundamental in helping get us on site, ready to respond safely, and the efficiency of our back office systems is crucial in driving these actions quickly and helping us get to site within those crucial 2 hours. We have teams allocated to on-call cover throughout the year, with an on-call manager, typically based at our Sheffield facility, as shown in this video, to oversee the call-outs and teams. Upon receiving a call-out, the manager will use our in-house intranet system, Insight, to review the structure. We can see if we have attended at that location before, build a safe work pack for the required ELR and mileage, and we can plan safe access and egress for the team and create an appropriate safe system of work. This safe work pack can then be made available to the site team instantly via their tablet or phone. Okay. Usually, response remits are received via a phone call, either from the asset engineer or the works delivery team at Network Rail. Response jobs can happen at any time. If we receive an emergency response remit during the week, day or night, our usual practice is to try and find the nearest team and divert them to the emergency works. But this is dependent on the types of works nearby and any other constraints such as traffic management, subcontractors, or possessions. Insight, our intranet system, shows the location of works planned for each day in a map format. This, alongside our telematics system, which shows the live location data of every single vehicle in our fleet, allows the on-call manager to identify the closest team to any 2-hour response, and we can divert them. This can then be in addition to the on-call team being called out, as the on-call team may need to divert to one of our depots to pick up plant and material to actually undertake repair works. If there isn't a team available to be diverted, or if the response has come through on a weekend or bank holiday, then we need to alert and send just the on-call team. We don't divert anybody. And that means that we don't disrupt the operatives who are already working on more constrained possession shifts. Insight has both desktop and mobile versions. There's always an app for that. And it handles all sorts of business data, from timesheets and vehicle inspections through to safety, commercial and project data on all of our activities. The system is constantly evolving and growing, helping us to make better use of our data to drive efficiencies and improve safety. The extract currently on screen is the list and location of all public defibrillators. And this proved beneficial recently when we had a team down near Luton Airport on the week of the fire. But luckily there was actually a happy outcome on that occasion. With all of our data, both internal and external, being collated on one central database, we have the ability to create a safe work pack which includes the ELR, mileage, access and egress points, the relevant section of the hazard directory, and the signal diagram for the location in question. This can be completed by the on-call manager, and then, as I said before, the site team that has been diverted can access it immediately on their tablet or phone, saving us precious time. The works are briefed by the manager to the team to ensure that they are aware of the response requirements. Is it a make safe? Is it an assessment? Who do we need to contact at Network Rail? And the manager also lets them know access points, the most likely safe system of work, whether it's separated, line-side request, or whatever else we need to do. Some lovely photos of our depots there. So our on-call team can then collect any required plants and materials from the nearest depot. We do have several. We've got them in Sheffield, Ferry Hill, Leeds, Colchester and London. And they can do this on the way to site. They can also pick up a printed copy of the Safe Work Pack, and they can also take the on-call pack, which includes sufficient basic paperwork, such as an outline task brief and risk assessment, that they then review with the manager when they get to site doing a point of work risk assessment. The team will then take the plant materials and Safe Work Pack and make their way to site. And this is where I hand you over to my colleague Kieran, who will discuss the delivery aspect of our call-outs. Thank you.
Afternoon. So I'm going to be talking about the delivery of the works that once we're on site, and that's going to start at day one. So inevitably, with sort of landslides or failures that affect the operational rail, there's going to be plenty of stakeholders involved, as you can see from all the traffic cones there on site, and then we've got to be able to deal with that. And these questions can involve how much it's going to cost and how long is it going to take. Approach to each response is going to vary depending on what's happened, and CML has sort of learned that in the last 30 years of experience. But today I'm going to be talking about some of the key principles that we apply to each project, which allows us to deliver a effective response. And that's starting understanding the problem. So when we get on site, we've got to determine the cause and the extent of the failure. This can include water ingress, which causes translational or rotational failures, as we've discussed today. But there's also other things such as rock falls. We've got voids from burrowing animals, and also fires, as you can see from a recent project with a thermal image on screen. Our first point of call will be to get in touch with our geotech specialist designers, and they'll come out to site and undertake investigations with CML and Network Rail engineers as well. It's also important that we get pegs in the ground as soon as possible. This gives us an understanding of the depth and the extent of the failure, and this also evolves as time goes on, so it gives us a better understanding as works continue. It's also important that we identify our constraints on site, whether that be access options. So as Natasha mentioned before, we have the Insight database, which provides us with a list of access options for each asset. When we're on site, we're able to identify these options and then make a decision depending on certain restrictions, be it loading restrictions or clearance for getting onto site. And we also have to consider other restraints. We will undertake environmental surveys from day one, so this can identify protected species near site or potential designated sites which we can avoid, or work our methodology around ensuring that we don't affect these, or work our best to reduce impact. I'm going to talk a bit communication and collaboration, which sort of seem quite buzzwordy and sort of cliche. However, they are vital for this process when undertaking these emergency repair works. So, as I said, there's going to be plenty of stakeholders and everybody's going to want to know what's going on. And it's important that we immediately establish lines of communication. Important to understand who's representing each party, be that client, managers of the track, overhead lines, etc. It's also important that we know how often we're going to report, so weekly, every day, and also by what means, if it's something as simple as a WhatsApp group or a Microsoft Teams call, or more formal meetings on site and through the office. It's important that with all these stakeholders on site, we use the wealth of knowledge and experience of each of them. A good example being an asset engineer. If they've previously worked on said asset, they're going to know things that have happened there before that we can benefit from. Or even someone such as a landowner who might have a local knowledge of the site that we're working on. It's important that we utilise this information as it can provide resolutions to issues as we continue with the works. We also need to understand the requirements of each stakeholder and take them into consideration throughout the project. We'd love to answer the questions in terms of how quickly can we open the line. We like to do that straight away, but we can't accurately. But through this collaboration, we're able to come up with solutions, be it a berm construction or sheet piling. And from that point, we can provide draft programs and deliverable dates. And that's going to allow us to answer some of these questions that the stakeholders may have. Through this communication and collaboration, we're able to define the scope of works and also the desired outcomes that every stakeholder wants. And this gives us that needed clarity that we probably didn't have at that day one stage that I showed you before. Then we get into mobilisation and the challenges that we face. The big one with these emergency works is going to be getting resource to site as soon as possible. CML makes use of its emergency response unit, which can get basic materials and essential safety items to site at the earliest opportunity. And we can do that independently because of our response unit. So we're not having to use other people where necessary. We can also identify local supply chains and subcontractors using the Insight database. We link our Insight database to mapping data, as you can see from the screen here, and this allows us to filter out local suppliers on a set radius from the said site. We also have agreements with all our key supply chain partners for 24/7 on-call service, which provides the opportunity to give rapid out-of-hour response when required. And CML also has their own in-house fleet of civils plant, which we make use of as well. And then once we're on site, we can often find we have concerns from residents or local businesses. And to deal with this, we make sure that we keep conversations going, maintain understanding and transparency between all the parties. Finally, I'll accelerate design and delivery, which I'll deliver quickly because I've only got a couple of minutes. When we're on site, we're always making sure that when we respond to these emergency responses, we're using proven and experienced designers. And not only are they technically capable, but they also have years of experience in these landslide situations. They're able to provide sketch drawings, which can benefit from soon enough, and then therefore after they can go on and provide calculations. They're also able to adapt the designs to use certain materials that are available. An example being Mexborough on screen there, which used a specific pile section as it was locally available to get onto site quickly. We can also use standard details as this speeds up the process and provides the client with a bit of comfort that we're using a familiar, tried and tested design. And we can also use Form G schematic diagrams or agree with Network Rail to provide retrospective Form B designs, which also condenses the design program. Delivery of the works can provide opportunities for accelerated delivery. For example, if we have line closures, we can benefit from using RRV plant, as we discussed earlier today. And it also provides us with emergency powers if we need land access. However, there are often constraints which can prevent this. For example, if we're working near residents, we might be affecting them with noise and vibrations, which might prevent night working. We might struggle to get materials to site on weekends, depending. That's why we have our agreements. And also, we have to consider our fatigue management of our operatives on site as they're key to the delivery, and we want everybody to keep on working safely. Thank you very much. I'm just going to hand back to Charles, who's going to recap.
So I'll just take a minute just to quickly wrap up. In terms of what works well, we know that simple interventions, clearing drainage systems before and after weather events works. We found that the creation of a centralized digital system, not only has it helped our teams in preparing safety critical information quickly, but helping them respond faster, but it ensures our teams are well informed with all the available knowledge that we have. But probably most importantly, we can't underestimate the value of the people here. How we effectively communicate and collaborate between the various organisations plays a huge part in the successful outcome of these emergency response jobs. There's always going to be areas we can improve. We know we have gaps in how we share data between client, supplier, third-party systems, and we're always working hard to see how we can deliver solutions quicker and better. But if I can just go back to one of the first slides, or the titles on one of the first slides, are these events preventable or inevitable? Whilst we continue to invest in technologies to monitor, maintain and prevent, we can't currently afford not to be prepared for the inevitable. Thank you.